All right, welcome back for another one. Today we have in a NerdQaxe Hydro. Kind of an interesting, unique design here. Seen a bunch of different hydro miners in the market. Customer's complaint is current protection keeps popping up and images inverted upside down. The customer sent in 3 units actually for us to take a look at, so we're going to go ahead and take a look at this one first and see what's going on. Now, I installed one of my test displays. He did ship with his display. I did validate it's working, but before I change any settings, if I don't suspect a problem with the display, I don't mess with the customer's display. I just make sure the display actually works. So let's take a quick look here and see what this thing is doing. So plug in power. Take a look here on the PC. Let's pull the dashboard. So it's booting up. I've got my 1.2 volt, basically my look-ahead voltage at the ASIC voltage measured. It's dropped to 0.57, and I just got my error message on the screen, and now 0 volts. So now let's take a look at the thermal camera, and let's see what this thing is doing under a thermal camera. All right, so we'll get this footage recording for you guys. Okay, I'm going to reboot it. And we're going to take a look and see what happens here. It's going through reboot cycle. And instantly, the very bottom VREG closest to the ASICs is lit up hot. 82C, 84C, 86C, 90C. Now it just fired up the other 2 VREGs. You'll see that in the footage here in a second. And then it just tripped. It has recycled, actually power cycled the unit, so it's going to do it again. Yep, just did it. Cycling again. So the unit is now in a loop where it is cycling over and over again on reboot sequence because it's seeing this error. Lights up that bottom VREG, goes to town. So that's our symptom. That's what we see going on with this. Okay, go ahead and shut that off. We'll let that cool down. I'll kill that. Should be able to see that footage here on your screen. You can kind of see what I'm seeing here. So we'll go ahead and take this apart, get this off this board mount, and we will take a look and see, do a visual inspection on the board. Again, this is all part of the evaluation process. We'll do a visual inspection. We'll try and find out if there's anything else going on, any other bad components on the board visually, and then we'll give the customer an estimate on replacing the VREGs. That's really what this looks like. Appears to be the issue here. Again, this customer sent in 3 of them, which isn't a problem, save a little bit on shipping. Just filled out a form for each one of them. Unfortunately, in the description, he kept the same on all of them. At least that's how it came across in the system. And they could all have the same problem. We're gonna know in a few minutes as I go through each one of these to do the evaluations. So I've got the board separated from basically the radiator mount assembly here. Pull the main heatsink off, and then we'll take a look under the microscope. I like these hydro assemblies. I think they're pretty cool. We tested some at Ixtech to see if we liked the performance. The biggest problem that we found with these is VREGs, keeping the VREGs nice and cool, because you lack a fan on the front side to send some cooling down. Looks like we've got some pink thermal paste. And then something else here going on. Let's take a look. Not a fan of that rubbing that we see here, but we'll take a look further. You see this dark color here, that's typically, yeah, indicative of some rubbing that's been going on, or we're actually losing some of the contact material. That tells me that the vibrations are rubbing against the top of the ASIC. So as we take a look, we just need to look closely at that. So let me set this aside. Get our brackets over here out of the way. And we'll take a look at our board. All right, there's our suspect ASIC, and as we often see, or excuse me, our suspect VREG, as we often see, we're seeing the temperatures pushing out the residual solder flux that's underneath the CST chip here. So we know that thing's getting really hot. I don't see any resistors or caps in this circuit that look to be cracked or damaged or burned. Let's continue our visual inspection here. Got some copper heat sinks on the top, which, okay, copper heat sinks on the top of the coils. All right, that's fine, help. But without a fan blowing over the top, we're not really dissipating that heat. We're adding more thermal mass, which is, again, fine, but these things, especially after running long periods of time, the real big benefit you're going to get here is if you actually have a fan blowing down on top of them. 8 amp fuse. Everything here looks good. Let's take a quick look at these ASICs. We'll get them cleaned up. Again, during evaluation, I try and look for any cracks, any issues standing out, and we're going to look to see if we can see that rubbing and see if that transfer we saw was from the heatsink or from the ASIC with that extra material. Oh man, this thermal paste is pretty thick. It kind of looks like the Cryonaut thermal paste. But I don't know. I didn't put it on, so I'm not sure what it is. For thermal paste, we use MX6 or MX7. We find that for cost to performance, it actually performs extremely well. So we ship all of our miners with MX6 or MX7, just depends on which miner. All right, that silicon looks good. That looks pretty good. There's our transfer. And so we can see here the rubbing that has occurred as it's starting to take off this coating on the outside edge of this chip. And that's what we saw in the thermal paste, was that material coming off. So eventually this is going to create a problem if it continues to rub like this, and it could be the way it's mounted. I mean, there is a pump in the head of these hydro units, so that pump is constantly spinning and vibrating, so eventually it's going to take its toll if there's any movement at all, and it acts like, you know, copper to this is going to act like a little bit of sandpaper. So not sure how old this unit is. Looks like we got PF chips in here. Not sure what those are anymore. Looks like they're all from the same batch based on the number I see here. Okay, let's check the back side real quick. Everything here looks pretty good. Temp sensor for the VREGs, which is on the back of the unit. Got good solder joints here. So this board is actually, not sure who manufactures this one. It is a little bit different than the original design. There would typically be a jumper here at the top that allows you to control the voltage going to the controller chip, so that you could do, as you assemble it or you troubleshoot it, you can isolate that circuit out pretty easily, but that is not on here. So that is not part of the original This is not made to the original KiCad files, which is fine. Those are TI VREGs, which is good. Another Texas Instrument chip there. 1.8 or 1.2 and 0.8 volt. And 5 volt. Okay, so I'm going to give this customer estimate to replace the bottom VREG on this unit. So as we saw in the thermal camera image that I shared with you guys, you can see that as soon as this thing lights up or powers up, that we're getting a current draw through here. So we saw during the cycling process that the other two are getting activated by the controller chip. So what we likely have is a short here that's picking up that look ahead voltage and triggering this CSD to turn on. So we're not, excuse me, we're not drawing enough current to pop the fuse. On this, we don't have a dead short, but we are getting definitely a bad behavior on this chip. So we're going to give the customer an estimate to swap this out. And if he approves it, then we'll do the repair right here on the channel. Thanks for tuning in.